You know that feeling, right? You're strapped into a roller coaster, that slow clack, clack, clack as you climb a hill that seems to touch the sky, that heart-stopping pause at the very top, and then that incredible, scream-inducing rush all the way down. It honestly feels like pure magic, but it's not. It's physics, pure and simple. Today, we're going to use that thrill to understand some of the biggest rules of the universe. So, let's get into it.
This is the big question, isn't it? It's what our friend Ria was thinking about on her last trip to the amusement park. It seems pretty straightforward, but the answer to this one question unlocks the entire secret of the ride. We're going to break this whole mystery down piece by piece.
Okay, so it all starts right here. That slow, almost agonizingly suspenseful journey up. You're being dragged by a lift chain, and that chain has one super important job. It's fighting gravity for you. Every single click you hear means the car is getting higher, and in physics, height is literally everything. The ride is basically storing up a ton of energy for the amazing chaos that's about to happen.
And that brings us to our first key idea, potential energy. Just think of the roller coaster car like a battery. That lift chain, it's the charger, plugging the car in and filling it up. But instead of electricity, it's being charged with energy just because of its height. The higher that car gets, the more of this gravitational potential energy it stores up, just waiting to be set loose.
And here we are, the very top. For that one single terrifying moment, you're just hanging there. The car has pretty much stopped moving forward. It's just creeping over the edge. Now, this is crucial. At this exact moment, your energy from motion is basically zero, but that stored energy, your potential energy, is at its absolute peak. The battery is 100% charged.
And then, whoosh, it happens. The car tips over the edge, the chain is gone, and gravity completely takes over. That calm, charged up feeling from the top, it's gone in an instant. This is the big moment of transformation, where all that energy you stored up begins to change into something else entirely.
And that something else is kinetic energy. You can just think of it as the energy of pure speed. As the coaster plummets down, it's basically trading its height for speed. All that potential energy that was so carefully stored on the way up is now being cashed in and converted directly into the velocity that's pinning you to the back of your seat.
So here is the payoff. By the time you've hit the very bottom of that first massive drop, the car is at its lowest point, right? So its potential energy is pretty much gone. But where did it go? Well, it was all converted into kinetic energy. And that's why you're moving the absolute fastest right at the bottom of the hill. You've spent all your height to buy maximum speed.
Okay, but what happens next? As the coaster uses that speed to zoom up the next hill, you can feel it start to slow down. That kinetic energy, that speed, is being turned back into potential energy, or height. But have you ever noticed that the second hill is never as tall as the first one? Ria noticed that too. Why is that? Did some of that energy just disappear?
Well, the energy isn't actually lost. It just gets turned into other things that don't really help the ride. You've got two main culprits here. First, as the wheels grind on the steel track, they create friction, which makes a little bit of heat. And second, as the car is screaming through the air, it has to physically push all those air molecules out of the way. That's air resistance. Together, that resistance and friction are what you hear as that powerful whoosh sound. So a little bit of your total energy is always being lost as heat and sound.
And this all leads us to one of the most important rules in the entire universe, and definitely for our ride, the law of conservation of energy. It basically says that the total amount of energy in a system, the potential, the kinetic, the heat, the sound, all of it, always stays the same. It just changes its form over and over and over again.
So when you really think about it, a roller coaster is just this giant, awesome, energy-converting machine. The slow climb up is for storing the energy, and the entire rest of the ride is just the thrilling process of spending it, trading height for speed and speed back for height, all while losing a tiny bit to sound and friction. You see, the physics isn't taking the fun away, the physics is the fun. And that's really the big takeaway here. This constant swapping between potential and kinetic energy, it's happening all around you, every single day. Think about a bouncing ball, or a kid on a swing set, or even a pendulum on an old clock. Once you start looking for it, you'll see it everywhere. So next time you're just out and about, ask yourself, where's the energy being stored, and where is it being let go?